So I'm creating an array of colors, string array. Red I put, blue I put, pink, orange, and so on. Okay. So I have an array of strings. They're all colors. I have another array delete array, again same colors. My intention is to remove from the first array whatever is there in the second array. Getting the idea? Whatever is the second array, pink and green, I have to remove from the first array. With the array it's very difficult. Okay, so my collection API or collection framework will come to help me. So let me create a list. A list, LIS control spacebar, Java util list, java.util.list. Take that. So that is the list, java.util.list. So I need to tell what I'm putting inside. In this I'm putting string. So that by mistake I do not put anything else. Somebody can change the code later and put employee inside that. It will take it because it's object. But now it won't take. This is called generic capability. You predefine it that in this list I am going to put only strings. Don't put any other class. Okay. So color list equal to new array list. Array list. Java.util.array list. Take that. Here no need to mention. Okay. Here there is no need to mention. Only one side is enough. So what I'll do, I'll put everything inside this. In a for loop, for each, FORE, control spacebar. I'm putting that color first. Later. Doesn't matter anywhere. For each iterable over an array. Or this color array I'm going to put a for loop. Use that for each iterable. So instead of string I'll put color. It looks better. How to read it? For each color of type string in color, everything, all of them. For each color of type string in color array, what I'm going to do, I'll transfer all this to my list. All this I'll transfer to my list. That is the list, color list dot add which one, color. second one. I transferred all the elements in my array into the list. List is an interface. List is an interface. I can't make object of interface. Array list is implementing list. So I'm making object of array list. Otherwise I can't write like this. It should be child of that. So sort this. Color list. And run it and see. Is it coming? It is printing as it is. Now how to remove that second one? Put this also in a list. One more I'll create. Delete list. Same for loop I have to put that also inside the list. For each color of type string in delete array, delete list dot add color. Delete list also will print. You see? So both are filled inside a list. How to remove now? First step is to get an iterator out of my main list. So there is a method called iterator in the list. It will return me an iterator. With the help of that I will manipulate it. So iterator Java util iterator. Okay, use that with string. Okay, this iterator Java util iterator iter equal to this color list dot iterator. So you can iterate over the objects in the list. It will be in the first list, first item it will be pointing now. So put a while loop, while iter dot has next. White iter has next means next element is there. Till then, keep on doing something. What do? I need to check if that red is present in the second one. Blue is present in the second one. Pink is present in the second. Pink is present, remove it. This I am going to do. So if the delete list dot contains what, iter dot next. If you say next and return the object, so that object will come back, it will come back. Has next will return true false, but next will return actually the object. Also the pointer will go to the second one. If it contains, what I'll do, iter dot remove. Making sense? In the while loop, I'll iterate across the entire list and I'll say each time next, 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 each time I'll check it is there in the second list. If it is so, iter dot remove. It will remove that particular object, whichever it is pointing to. Now what will happen? The reduced list will get printed. See, pink and green is disappeared. You're getting the output? Wait. Remove now. If it contains iter dot remove. In the if condition, you didn't write anything. It's empty. Iter dot remove. Clear now? So you see that the order is same, right? Whatever you added here, same order. List is an ordered collection. You can get it by the name number index. Okay, so now what is the index of this? Orange. What is the index of orange? 0, 1, 2. Print and see. Dot get 2. See, orange is come. You can get the value by the index. They're ordered and you can manipulate through index. Making sense? Able to understand this? Any doubt? Create one more class. The same package. Set list. And Again this one, string array, and put some repeat. List util java.util.list string There is one more way to get this list. No need to write loop but on that. Arrays. There's a class called arrays. Dot as list. Arrays dot as list. It will automatically convert into list. And pass the list to it. Okay. Pass the array to it. It will convert it into a list and give you. They must have written the same code what we wrote. No need to bother, just use it as a static method inside arrays. Directly you can use it. Arrays dot as list. Now you got the list. There is a interface called set. Java.util.set string. So it is java.util.set equal to new. This is the interface. So you need to use a class. Hash set method is used. Hash set java.util.hash set. Take that and pass it to that. Print it. Repetition is gone. It's as easy as that. Just create an object of set or job is done. Good. You're also able to get it. You do. Okay. So what did I tell you about list? List is ordered and indexed. You can retrieve the index. Whereas set is no duplicates. It does not allow duplicate. It's just now saw that. We create an object of hash set. It did not allow duplicates. Remove the duplicates. Now, how did it understand There are duplicates and it is trying to add. How did it understand I should not add? So M set test. I am going to add employees in the set. So create a set SCT control spacebar Java util set. I am going to add what? EMP. I am not adding string. Employee object I am adding. So EMP set equal to new hash set Java util hash set, in which I am going to add more and more employees. So to create it, it's not there, it doesn't exist. Create class EMP. Click on that. Okay, there you go. Put something in this private int id private string name private int age. These are the properties or the fields of EMP. Okay, create a constructor. How is the shortcut? Alt Shift S. Alt Shift S. In that you can see using fields, the third last one. O. O is underlined. Use that. Generate constructor using fields. Okay. Check all this ID and image and so okay. So I got a constructor using the fields. So directly I can make the object. New EMP, number, name, number. Directly I can make. Also, I can put some getter setter if I need it. Again, Alt Shift S. You can see getter setter is there. R. Use that. Generate getter and setter. All the getter setters are there. Get ID, set ID, get name, set name, etc. Also, I would like to print it. Put to string. How will I know which is the object? Again, Alt Shift S. S. It is here. Generate to string. There you go. All are ready. My object is ready. Okay. Only this string you have to type. These 3 lines you have to type. Remaining all Eclipse will do for you. All you have to do is only this. Remaining all. Fine. Now create the object. EMP class is ready. All 3 fields I put. I put the constructor for that. I put a getter setter method inside that. I put to string method also. Now I will add employees into this. Create it emp e1 is equal to new emp, which is having the constructor int id, string name, and int age. So first one will be number 111, then same 5 will make 2, 3, 4, 5. Change the IDs. Four employees I made using those constructor. I started adding it. Emp set dot add e1 What I'll do is, okay, let us see now. After this, I'll print it SYSO and that. Okay, we'll put a slash in for this. Put a backslash in. So it will print next line. In this case, I added in E1, E2, E3, E4, E5 in an order, but the output is not in order. Set is not ordered. It cannot have duplicates. So here it's fine, there are no duplicates. Suppose I add again. This first one I'll add again. I'll create one more. E6. Okay. I'll create E6 exactly identical to E1. E1 and E6 are exactly same. The ID, specifically the ID of employee is same. Cannot be allowed. ID cannot be same for two people. Now both all the name, age, ID, everything is same. I should not be adding it in the set. No duplicates. But if I add it also, you see that it is there. All the six are there. It did not remove the duplicate. Why? It doesn't know what is duplicate about it. When you look at it, you know it is duplicate, but the program does not know. There is no way the set can understand this is a duplicate, because you never told it what is it that is duplicate. Is it ID? Is it age? Is it name? You never told that. Unless you tell that, it will never decide what is unique about it. So since it's a hash set, to hash these objects in that queue, what it does is it uses the hash code of the object. Yes, it's not unique now. They're all different objects. That hash code is not unique. It's address of the object. All are different. There are 6 objects. All 6 are sitting in different memory locations. Obviously, they're all different. That is why the duplicate also came. Now you need to do one thing. There is something called overriding in Java. Override it. Override the hash code. And you decide what is unique. Call shift S, generate hash code and equals, or override implement methods. What I want? I want hash code and I want equals. These two I have to override from the object class. This is what is significant then. Object has these two methods and I am overriding these two. Done? Instead of writing this, I'll make some manipulation here. See, hash code has to return the int. The address is always integer. I will change it. I will return ID. One trick is finished. Now to hash your objects, the hash set will use ID, because it will call hash code. It will get the ID in, not the original hash code. I overridden one, so now it will get the wrong value, not the original hash code. So it will be fooled into thinking ID is my hash code. And if it finds the ID same, it will go and check everything else is also equal. How to check? Calling equals. It pass it here. It pass the EMP here. Second EMP is adding. It's found the ID same, hash code is the same it found. Then it will go and call equals. It pass that EMP into it, call the equals method. Is it true? It will check. If it's true, it will not add. Now it's 100% perfect that it is equal. So override that. So obj, okay, write this equal to EMP, because we know it is EMP, but the compiler doesn't know. To make the compiler happy, add cast to EMP. You're bypassing the compiler. You're bringing this object down to EMP. Okay, so this is actually, we know it is employee. If something goes wrong, it will throw class cast exception. Okay, now compare it. Okay. Even equal it will do. It will always get different. So return So return, compare all of them. ID equal e dot get ID. That is why I need getter setter. Check these two are equal. Directly you can compare. And also age equal e dot get age, and also name dot equals e dot get name. All three I'm comparing. Return the boolean true false. ID equal e dot get ID, and also age equal e dot get age, and also name dot equals e dot get name. All three are checked and returns true if all three of them are equal. Now see the difference. Where is it? 111? Only one is there. In fact, just check it. It's really calling that. Is it really calling this too? You see, it's calling. It calls the ID, hash code it called. See, one by one it called. In the last case, it had to compare. It found it is equal. There is 111 available in the hash table. So it compared with the equals method to determine whether the entire object is equal. That is your wish how you want to compare. Okay. The code has to be written by you. Override it and write the code. What is equal? Now you definitely told that said this is what I mean by duplicate. All three of them are equal, don't add. And if you look at the add method, it's returning boolean, true false. If it was unable to add, it would have returned false. Okay, check whether it's adding or not. This out. Okay, copy paste this. I'm putting a sysort across that. So whatever return value is there, it will print. See? This after checking it found it's false. It did not add it. The add method returned false in the last case, remaining all it returned true. Make sense? The add method in the set will return true or false, depending on whether it could add or not. So you learned two more methods in object class: hash code and equals and their significance. Try it and see. If you see, there is no particular order in which they are appearing. There is no particular order. Set is not ordered. List is ordered, but set is not ordered. But no duplicates. Now, let us see how to sort using collections. I would like to sort the elements in a collection. Create a class. Will be sort list test copy this. Okay, so this is a list, and if I print it, it will print exactly as it is. Okay. It is ordered. The same order is maintained there. It is not sorted. How to sort it? There is a class called collections. Okay. Dot sort. Pass the list to it. Sorted. So easy. Collections dot sort. That's all. Make sense? But again, same problem will come. EMP how to sort? On what basis to sort? That's a problem. You need to tell the collections dot sort, sort it on this basis, so and so basis. And how do you give the basis in Java? Interface. They all made ready-made things for that. Interface has to be given. How to reverse this? Comma collections dot reverse order. You see, it's returning a comparator. It needs a comparator for this. That's it. See? Let us do this with the EMP. New class EMP result. So first make the list. We'll add EMP here. EMP list. Okay. Create the list where we're going to put the EMPs and create the EMPs. Create all the EMPs. Add them. Print them. So here there is no particular order. In the same order we added E2, E5, E1, E4, E3. Same order is appearing. We didn't sort it. Let us sort it now. We know how to sort. Collections dot sort list. Use error here, comma, need to give comparator. We will make a comparator. New M comparator. We'll pass on our own comparator to it. So we have to create it. Create class M comparator. It's automatically C. It's implementing C. C implements comparator. You don't need a super, only EMP. Only EMP we're putting there. Make sense? It needs a comparator, give it. It wants a comparator here, give it. But it needs a implementation of comparator. The interface comparator is required. But you need to override the method, add unimplemented methods. To any other. Why so many have come? Only one it needs. So this is E1 and this is E2. Both are compared by this method. What your sort method will do is, it will take your list. Now it is need to rearrange it. Okay. To rearrange what it will do, it will go to that object, EMP object. It knows it will take the E1 and E2, first one and second one. It will pass it into this method, compare method, because you give it a comparator also. Two things you give, a list you give, a comparator. Each time it will take the comparator, it will call the method compare and find what is the integer returned, plus or minus. Correct? If it is plus, what does it mean? The first one is bigger than the second one. First one is E1, second one is E2. You have written code here to return some integer, for example ID. So if it say E1 minus E2, it returns a positive number. So it will understand the first one is bigger. It will interchange it to make it sorted out. The small first should be small. If it gets negative as a difference, it won't do anything. Make sense? This is the way it compares. So a comparator is used for that. Right? So you need to write a code here. So what I'll do is, in my case, ID I will compare. E1 dot get ID minus E2 dot get ID. So ID is my factor now. It will sort by ID. Obviously, I written ID. It will not sort by age now. It will sort by ID. So now it will be happy to sort it. Each time inside the emp list, it will take this first one and second one. It will call m comparators compare method, pass it here. So 111 it will get, and here 112. You will see if it is not order. If it is not in the order, it will interchange it. Okay, print again. See how it was first and now it is second. Initially 112 was first, now 111 is correct. 2, 3, 4, 5. ID is in the sorted order. Good idea? Because ID is what is determining whether it is to be sorted in that order or not. First one minus second one is it. So 111, the first is 112, then 115. It found there is a it's in order. Then it went to 115, 111, then it got positive value. It readjusted it, and so on. It will keep on doing it until everything is in a proper sorted order. See how nicely they put the code so that to avoid you trouble writing all the code. How much of effort is there? Take one by one, take the ID, compare it, nothing you have to do. Just do collections.sort, give a list to it, and give a comparator to it. Override that method compare. Then you write the code. What should happen? Check it. So what I'm doing this is adding the wrong order 25143 and I'm saying sort, passing the list to it, and then comparator for it. EMP comparator, okay. And the EMP comparator has to override the method in comparator, which is compare. It will compare to. If I write EMP here, that means need not cast it. It is actually object. Once I write this generic notation here, no need to write obj emp e1 is equal to obj casting to emp. Previously we did that. No need to do it. Okay, so we did here now. This is not necessary. Casting is not necessary. Directly we can write. Since we have declared it is comparator is having emp only. So automatically EMP will compare here. I'm comparing the ID. If I change it to age, now it will sort by age. See, it is sorting by age, not the ID. Because it went and checked that, compare each time for sorting. It got only age, so it sorted by age. You choose what you want to sort. Okay, got it? Clear? No doubt. Look at that one. So collection hierarchy, if you see, collection interface is the root of the entire collection hierarchy. It's an interface. Under this, there is set interface, queue interface, list interface. We use that list and set. Under set, you have sorted set. Under list, you have abstract list, which is implementation. Under set, you have abstract set as implementation, and queue you have abstract queue as implementation. These are classes under abstract collection. So collection is implemented by abstract collection under object. Now under abstract list you have array list, vector, stack. So array list we used, most widely used class. Then you have under abstract set you have hash set, that also we used, and tree set. We will see the use of that. Okay. And this is the interface set. Okay. Now here map is separate from collection. Root is the map. In map you store key value pairs. ID name, something like that you can say. Both are objects. Correct? So one object will become key, the other object will become value. That object can be a collection also. Yep, any object is okay. So you can have a set of values inside a value of the hash map. So you have hash table, hash map, linked hash map, sorted map, tree map. You can see the keyword tree. Tree means sorted. See tree set here, navigable sorted set. So when there is a tree, it is sorted. Okay. So if you are using a set, use a tree set. It's automatically sorted. That's a secret for sorting automatically. No need to collection.sort. use that class called reset. No problem at all. It's automatically sorted. Anytime you add, again resort it. One more you add, again readjust it. It will place in the correct place. It'll rearrange everything. It has to, because last adding. So if it's a second position, it has to push everybody out and bring in the second position. You can do this work. So. Okay, let it remain there. Sorted. If you use a tree set, automatically sorted. No need to write collections that sort around it. Because the default behavior of a tree set is sorted. So did you install Tomcat? You have? Did we do something on the Tomcat? We did. So what you need to do is go to the Tomcat folder. You run it also. Is it running? Tomcat. In the bin folder, there is startup.batch. Execute that. We run this startup.batch. It will come like this. Okay. Server startup in so many milliseconds. Okay. So once you start this, go to the web apps folder and create a folder, say test. In the web apps folder of Tomcat, create some test folder or some whatever you can give name. If you go here, something will happen. What happened? After this, something came there when you created a folder. Yes. The web apps is actually where this will be monitoring. Tomcat is monitoring what is happening there. Anything you do, it will immediately understand. So that will deploy it. Test is a project now. Okay, inside the test, create index.html. Any HTML file you create in Notepad, in the Notepad. Okay, open command prompt cmd and say ipconfig. You will get this number 192.168.0.102, something like that. What is the number you're getting? What is your IP address? Hmm? You will get this number. What is the number you're getting? So did you create this index.html? Great. It should be inside your whatever folder, test folder. Folder is created now. In that index.html you have to create. Put it here, only index.html. Not remaining, only index. Put it here. Okay. Open your browser. All of you open your browser. And type http://192.168.1 some other number. Don't put your number. What is your number? 5. You put that in. Her machine. Colon 8080. Press enter. You use her IP. Yeah, because running on 8080. See, if you see here, there will be a protocol. You see 8080. The server is running on 8080. Are you getting the welcome page of Tomcat? Tomcat is jumping up and down. Cats, cartoon, you can see that. Then slash, what is your folder name? Test. You give test. And what is our folder name? You give test slash test. You will be opening your index.html. Slash test. We'll be opening that index.html page in the other machine. So Tomcat is running on 8080. That is the reason you're giving the port number as 8080. All the programs in your machine, all the network programs will run on some port number. That is why if you run it now, you can't run it again. Same port to applications cannot occupy. See, I can access from my machine also. Before giving it to telling customer about it, you have to test yourself. HTTP local address is localhost or 127.0.0.1. Both the same. Okay. You can write localhost directly, or you can put the number 127.0.0.1. It's a loopback address. It loop back to your own machine. And then slash test. It will open index.html. It's opening this only. Okay. See, if you refresh, it will immediately reflect. See, whatever changes you make, it will reflect. And if you make a change and she is accessing it, she can see it immediately in the browser. It's a networked program now. Whoever is accessing it can see it immediately. Any change you make there in that page, immediately reflected. So what you're looking at is a web-based program. For that you need a server. The server machine will have a server running that's Tomcat in this case. There are many of them. WebSphere is there. WebLogic is there. Tomcat is freeware. WebLogic is licensed. 3 to 4 crores license. It's very powerful. For all practical purposes, Tomcat is sufficient. And your browser is the client's application. All the computers in the world will have a browser. So you have an advantage there. Client application is ready. The browser understands only one language, is called HTML, Hypertext Markup Language. HTML is the mother tongue of the internet. So when you access another machine's page, what is happening is through the network, it went to the router, from the router it came back to you. The entire stream of characters is in the machine. The browser took it, interpreted the tags, like all these tags and all that. What is all this? It understood, it rendered on the page. It's called rendering. It's showing it here. So it interpreted H1 as something. The header tag. H1 is the header tag number 1. Up to 6 we are having. H1, H2, H3, H4, H5, H6. Smallest one is 6. There are header tags. And this is P, paragraph. You can create a table. All the tags you should close it properly. You can have table header again, page, then you should have a TR, table row. TD is table data. Okay, if I refresh it, you can see the table. There is no border, so you should put a border here. One. Everything should be double quotes. Okay, so these are all tags what you see. The table tag is a th, table header, table row, table data. These are all tags. Head tag is a this gives the header information for your page. Title is your title here. That will come here. And browser's title, whatever you written here, it will come as a browser's title. So whatever is in the body will get rendered in the body part. You can give background color bg color equal to for the entire body. Now if you refresh it, the entire body color has changed. You can also give style sheet here. Style in the header you can give it and give body braces. You can give background hyphen color colon. Remove this. This is called CSS, cascading style sheet. So giving a style to that. So defining your body is background color yellow. So the body gets that style. You can also give number. Red, green, blue. Hash. Some number you can give as this. Okay. This is red, green, blue. D1 is red, E4 is green, A4 is blue. Hexadecimal. Hash means number. You can also put the CS separately. Okay. dot css. I can copy paste that here. This value, put it here. It is in CSS file, and put here link. So we can put it outside also. So just put the reference here. Link native style sheet. href equal to the name of the file with the .css, and put that inside the CSS. Advantage is that any other file also can refer to it. There are many HTML files in your project. All of them can refer to the common CSS file. Okay. Okay. We are not able to see the page. You didn't refresh it. HTTP has a weakness. It's HTTP, right? Hypertext Transfer Protocol. The protocol, the rule obeyed by all the browsers and all the application using HTTP is using that protocol. What happened was your browser is gone to sleep. You modified that page. You didn't tell the browser, I have modified the page. How will they not refresh it? Right? HTTP's weakness is that it is stateless protocol. You asked for the page, you got it. And it said goodbye. It doesn't know you are there. You went for tea, you went for lunch, it doesn't know. You refresh it, again it will give it. So you refresh, you got it again. Then latest page you got, the modified version you got. So there is no communication between the client and server continuously. There is this called stateless protocol. The state is not known to the client or the server. Server doesn't know you exist, you don't know server exists. You ask for the page, you got it. Then after 1 hour again ask the page, again it will give you. And every time it is goodbye. Take this page, goodbye. That is why it's called stateless protocol. It doesn't retain the state. It doesn't know about you. It's a problem because banking application needs your login. It needs to remember you are the same person. Correct? Flipkart. You'll buy many items. How it will remember you are the same person? For that, we'll have some techniques to remember the client. Okay, see what I changed here? This one I wanted red color. So I said P, the style is color red. Also you can put background color. See? Background I said yellow. All the styling you can give with through CSS. You can put a button here. You want user to click something. So write it as input type equal to button. Value then button will appear here. See? Put a BR here. BR means break. Okay? BR is break. One line will extra. See? One line extra came here. And if you want something to happen when you click, you have to write functionality for it. You have to write a function for it. It is supported on HTML with JavaScript. That's right. The application which you have written, this one has been hosted on your server. It has been hosted, we call it hosting, at port number 8080. You need to tell your client what is your IP address and what is the port number and what is the folder name, that is your project name, test. That's the only thing they need to do. Right? And from there you'll keep giving link, href, you'll be giving links there. Fine? So enough for today? Tired? Tired? It is anyway almost 5 o'clock now. So any doubt from this? Okay, just see the functionality here. Here we'll write on click equal to JavaScript colon alert you clicked me. Write this here. That means this if this button has been clicked, it will trigger an event called on click. These are all HTML events inside the HTML design. So on click equal to JavaScript colon alert, you click me. Refresh. See, the client will see this. You cause something to happen on the browser, client's machine. Then it's working. JavaScript is working. Follow here. You can shift it to the script also. Shift it here. Head. Less than script. Script. Okay. Here write function show put that here. Alert, you click me. Right here. This is your function, and here is called that show open close. So it's actually calling the method available here. See, because I do not make it a messy code below. I shift it to a neat area. Not only that, I can shift it to another file also, just like a CSS .js file. Put it there, and then put link here. Script src is equal to that file name, and there you don't need to write script. Just write the function there. Interesting. You need to write programming behind the scene. It's only static and little front-end JavaScript and all that. But what to do with the commands which is coming into the server, you need to write program, Java program for that. That will be written in servlets or JSP. You'll be learning that in advanced Java. Is it working? JavaScript? Script tag you have written. Shift it to script tag in the head area. And call the function whatever you written.